So we've got now energy. Let's hit the equations here. We had just done this in class, so I'm going to go through this stuff pretty quickly. Work, W is work. All right, that's unit is joules or Newton meters. Same thing, force times distance. Force is force. We already talked about F on the previous page, but I'll just reiterate it here. Delta X is still distance or displacement. That's going to be meters. Delta E is change in energy. All right, that's going to be joules or Newton meters, either way. That can be change in any type of energy. That can be change in kinetic, change in gravitational, and so on. All right. A lot of the stuff here I'm not going to list, but some of it I will. So KE is kinetic energy. We typically just call that joules. PEG is gravitational potential, also joules. PES is spring potential, also joules. I guess I need to go back and tell what H is. H is the height of an object. That's going to be in meters. G is G, M is M. We already listed those out somewhere before. K is spring constant. And that's newtons per meter. X is spring compression distance. That is in meters. Should be an S on this. Fs equals, I don't have it on the equation sheet either, rats. Spring force. Did it get deleted? Or did I just mess that up? Huh, weird. Spring force. And that X and that K are the same here, and that will be in newtons. Holy cow, graph diagrams and extra notes. Well, energy initial must equal energy final, right? So we can have those bar diagrams. PG, PES, KE, PG, PES, KE. Whatever I start off with, I have to end with. So total is conserved. Right? Total energy is conserved. That's a super important fact. When something's off the ground, it has gravitational energy. Once there's a spring, there's spring energy. If it's compressed, when something's moving, it has kinetic. One thing that's not shown here is E internal, which is internal or thermal energy. Very important. That is also in joules. It's caused by friction, work done by friction, air drag, that sort of thing. Next thing we have to probably think about is the fact that work causes a change in kinetic energy. Work done is always equal to change in kinetic energy. That's very important. So let's look at the two energy problems. right, don't know if I'm going to be able to get to this. I did these in class yesterday, so I'll start writing them off, get as far as I can in the next few minutes, and then I'll post the finalized solutions. I did these in class once already. So work is force times distance, so it's 12 newtons, and it's positive, times positive 6.0 meters. 12 newtons, 6 meters, that's going to be 12 times 6, 72 joules of work. Should be 12 newtons here. It's my bad. Forgot to change it. The work done equals the change in kinetic energy. So 72 joules equals 1/2 mv final squared, right? Because KE final minus KE initial. K initial is 0 because initially it's at rest. All right. So 72 equals 1/2 of 4 times V final squared. Multiply both sides by 2. That cancels this out. Divide both sides by 4. That cancels this. We get V final squared equals 2 times 72 divided by 4. 36. Take the square root of both sides. You get V final equals 6.0 meters per second. So we found the work done. Set that equal to the change in kinetic energy. If friction did work on it as it slid, would its speed be greater or less than? Less speed. Because the friction is taking away KE because the work's negative. How do we know that? Because work being negative tells us that makes a reduction in kinetic energy. All right, this one here, like I said, we did in class. The initial energy is all spring energy, so PES equals 1/2 kx squared. So 1/2 k is that 500 newtons per meter. X is 0.15 meters, how far the spring is compressed. 0.5 times 500 times 0.15 squared. Oh, it ends up, oh yeah, this is the one with the weird units. 3, 6. I got 5.6 here. 4.5, 1.5, I'll say. So 5.6 units of spring energy initially is what I have. All right, up here, I know that there's 1 joule of internal energy built up. That's E internal final. I got to figure out what the PEG is over here. So it's 0.mgh. So it's 0.50. So up here is PEG and KE and internal. Initially, it's all PES, right? So this is like your initial and final. So down here, MGH, 0.50 kilograms times 9, I'll do 10 newtons per kilogram, times the height is 0.30 meters, 5 times 10 times 0.3, that's 1.5 joules. So that's a nice amount of gravitational energy. All right, so I started with 5.6 joules of energy, right? So this was 5.6, this is 1, this is 1.5, right? So whatever the kinetic energy is, it has to add up to 5.6. So if I just do 5.6 minus 1.5 minus 1, that means it's 3.1 joules of kinetic energy, all right? And if the scale lines up here. So that must be 3.1 to make the math work out. Final speed of the cart at the top of the ramp, well, KE at the top of the ramp equals 1/2 mv squared. So 3.1 equals 1/2 of 0.50 kilograms times v squared. Multiply both sides by 2. Ooh, I'm up against the bell here, but we're going to make it. So 2 times 3.1 divided by 0.5 is 12.4. That equals v squared. So v equals the square root of 12.4. V equals 3.5 meters per second.